मैं दिलीप कुमार जैन पीजीटी फिजिक्स केंद्रीय विद्यालय नंबर 1 उदयपुर आपके लिए क्लास 12 की फिजिक्स की ऑनलाइन क्लास लेकर के आया हूँ। मेरी पूरी कोशिश रहेगी मैं आपके सारे डाउट्स क्लियर कर सकूँ। तो इस वीडियो में मैं फिजिक्स के चैप्टर नंबर 1 को लेकर के आया हूँ और इस चैप्टर को मैं 5 पार्ट के अंदर कंप्लीट करने की कोशिश करूँगा। तो चलिए स्टार्ट करते हैं अपना आज का वीडियो।
Electric charges and fields. First of all, electrostatics, the study of electric charge at rest. In this, we study of forces, fields, and potential associated with static charge. Means charge remain in stationary conditions. Next, electric charge. What is electric charge? As we know that every atom is electrically neutral. Number of protons equal to number of electrons. Protons reside inside the nucleus and electron orbiting around the nucleus. The exchange of proton between atoms is not possible due to strong nuclear force, and the exchange of electron between atoms is easily possible by various processes. A negative charge atom, the atom having excess number of electrons, means the atom having extra number of electrons. A positively charged atom, the atom having deficiency of number of electrons. The charges were named as positive and negative by American scientist Benjamin Franklin. We find that like charges repel each other, means plus plus or minus minus repel each other, and unlike charges attract each other, plus minus or minus plus attract each other. Next very important device is gold leaf electroscope. It is a simple device to detect charge on a body. It consists of a vertical metal rod housed in a box or a bottle with two thin gold leaves attached to its bottom end. When a charged object touches the metal knob at the top of the rod, charges flow on the leaves and the diverge. The degree of divergence is an indicator of the amount of charge. In this figure, we can see that this is metallic rod. This is a positive charge rod. This point of contact metallic knob. Here we can see that two gold leaves. When a positive charge is in contact with this metallic knob, the charge is flow through this and these two leaves diverge. By this scale we can see the degree of divergence. If charge is less, then this force of repulsion is less. If charge is more, then degree of divergence is more. Conductors and insulator. Conductors which easily allow the electricity to pass through them. In insulator, the insulator are the substance which do not allow the electricity to pass through them. Second point of difference, conductor have free electrons. Insulator do not have free electrons. Third one, charges remains only on the surface of the conductor. When we charge given to a conductor, charge remains only on its surface, but charge is distributed through whole volume of the substance. If charge is given to an insulator, then this charge is uniformly distributed to its whole volume, means charge cannot remain inside the conductor. Fourth one, example of conductors, metals, human body, animal body, and earth. These are the four important examples of metals. Examples of insulator, non-metals like glass, plastic, nylon, wood, etc. Very important property of conductors and insulator. Conductor means low resistance and low resistivity but high conductivity. But in insulator, high resistance and high resistivity and low conductivity. Charging by induction. This is the process of charging of a body without bringing contact with a charged body. This process contains total 5 steps. First step, step A. Bring two metallic sphere A and B in contact as figure A and B. In step B, bring a positively charged rod near to sphere A. Negative charge on sphere A on left side and positive charge on sphere B on right side. The process is called induction of charge and take place instantly. Now in third step, we separate sphere A and B by a small distance in the presence of positive glass rod. In step 4, we remove positively charged glass rod and then we see that the opposite charges, the negative charge now shifted to right side and positive charge shifted towards left side. Now in step 5, now separate two spheres by a large distance, then charges on sphere A and B get uniformly distributed over them. This entire process is known as charging by induction. Basic properties of electric charge. First, what is point charge? If the sizes of charge bodies are very small as compared to the distance between them, we consider them as point charges. Now, first basic property is additivity of charges. How charges are added? The total charge of a system is the algebraic sum of all the individual charges located at different points inside the system. Here one system is given at various locations, different charges are located. The total charge Q equal to plus Q plus 3Q plus 6Q plus minus 5Q plus minus 4Q plus 5Q. First we add positive charges and negative charges. So we get 15Q as a positive charge and minus 9Q as a negative charge. So resultant we get Q equal to plus 6Q. Now next one is quantization of charge. Very important property. The charge Q on a body is always integral multiple of a basic unit of charge denoted by E. Hence Q equal to NE. Means charge is always integral multiple of this basic charge unit E. Charge can not be as Q equal to 2.5 E, 1.3 E. Charges is always integral multiple of E, where N is an integer, positive or negative. Charge on electron minus E equal to minus 1.6 into 10 to the power minus 19 coulomb. Charge on proton equal to plus E plus 1.6 into 10 to the power minus 19 coulomb. So 1 coulomb minus 1 coulomb is equal to minus E upon 1.6 into 10 to the power minus 19, or 1 coulomb is equal to 6 into 10 to the power 18 electrons, or we can say that minus 1 coulomb charge means what? 6 into 10 to the power 10 to the power 18 electrons constitute minus 1 coulomb charge. Clearly 1 coulomb is a very big unit of charge. We use its some submultiples as micro coulomb. 10 to power minus 6 coulomb, nanocoulomb 10 to power minus 9 coulomb, 1 millicoulomb 10 to power minus 3 coulomb. If a body contains n1 electrons and n2 protons, then total charge on the body is given by Q equal to n2 into E, or we can write plus E plus n1 into minus E. Plus E is the charge on proton, minus E is charge on electron. So Q equal to n2 minus n1 E. Since n1 and n2 are integers, so their difference n2 minus n1 is also an integer. Thus, the charge on any body is always an integral multiple of E. Third important property, conservation of charge. According to this, the total charge of an isolated system remains constant, or the electric charge can neither be created nor be destroyed. They can only transfer from one body to another body. This is a basic natural fundamental law. The charge of the entire universe remain constant.